This is the Water Table.
A chance to hear the agricultural side of these issues.
Place for people to go find information and education.
Water management is just going to become even more critical into the future.
How misunderstood what we do is.
I would encourage people to open their minds and listen to this dialogue.
Hi everyone, Jamie Dunnick here with the Water Table. We had a great time last week, our team did, at the North American Conservation Agricultural Drainage Expo, first ever expo that they've had in Des Moines, Iowa, and just heard a lot of great things. I was sorry I wasn't able to be there, just my schedule didn't allow last week, but Prinsco decided to host a few podcasts during that time, and I think you're going to really enjoy them. Trey Ellis with Prinsco, he's an application engineer and has been really involved in the agricultural side of our industry. He's got a farm background, is a farmer, and is really passionate about water management. And I've had Trey on the podcast before. And Trey did a couple of podcasts down at the show for us. And first he did one with Dan Currence. We're going to share that now. Dan is the director of drainage division for PPI, friend of mine. Oh, sorry I missed you, Dan, at the show. Wanted to be the one to interview you, but I heard great things about your conversation with Trey, and I think listeners will enjoy it a lot. But just some of the content in there is forward motion on recycled resin practices that's happening within the plastic pipe industry and the Plastic Pipe Institute. They talked about product resiliency. They talked about service life, disruptive events, what are pipe stressors and recovery and sustainability. So just an action-packed episode here of the Water Table with Trey Ellis and Dan Currence. I hope you enjoy it.
Welcome back to the Water Table. My name is Trey Ellis. I'm an agricultural engineer, application engineer with Prinsco, and have been there for a handful of years, filling in for Jamie Dunnick here, who's been away. We're here at the North American Conservation and Drainage Expo down in Des Moines, Iowa. First year of the show down here. And got my guest with me is Dan Currence with the Plastic Pipe Institute, director of engineering with the drainage division. Has joined us here. Was able to speak at the conference a little bit and spread some education. But to kick it off a little bit, Dan, tell me a little bit about your background and experience within the drainage industry.
Sure. Thanks, Trey. Thanks for having me. It is good to be here at the Expo, as it is. I have a degree in civil engineering and a master's degree in environmental engineering. I spent some time in the Navy and some time in consulting engineering, but have spent the last 25 years in the plastic pipe drainage industry, and the last 10 with Plastics Pipe Institute as director of drainage division, covering corrugated pipe used in drainage applications.
Mm-hmm. So with the Plastic Pipe Institute, you said you're a lot focused in the drainage division, but what else does that PPI? What else do they cover? What other industries?
So PPI is a trade association covering all kinds of plastic pipe used in a variety of applications, and pretty much all plastic except PVC. And then we're organized according to the applications. So there's a division that focuses on building the water line inside, the red and blue lines inside your home. There's a division that focuses on gas, natural gas lines, conduit, and pressure water, so water mains. All those are solid wall pipe applications, and so the drainage division is the only one that has corrugated pipe.
Gotcha. Yeah, and that's kind of where your bread and butter was with a lot of your career, and likewise with mine as well. So maybe talk a little bit about what PPI, what their role does within the drainage industry. There's it's a handful of other manufacturers that play a role in that too. But from PPI's seat and your seat, what do y'all get involved with?
Right, that's a good question. So PPI, our membership includes manufacturers, and there's 12 to 14 pipe manufacturers, and this is North America, so Mexico to Canada. And so we have the pipe manufacturers, but we also have all the resin suppliers, equipment providers, kind of ancillary products, gaskets, fittings, and things like that. So we have a variety of members. Within drainage division, there's nearly 50 members, and so there's more non-pipe manufacturers than there are pipe manufacturers, but clearly catering to the pipe manufacturers and what the needs are. So what we do within drainage division, a couple of things. We focus on standards, both material standards, installation standards, things like that are governed by two primary bodies. Well, I'll say three. Includes AASHTO, so for highway, so we get involved in the standards that are developed for highway use. ASTM, which is American Standards for Testing and Materials, so that's another group, another body where a lot of standards originate and are tweaked on a regular basis. And then I also get involved in the Canadian Standards Association, so CSA. Very similar to ASTM, got their own procedures and things, but so that's really the big part of standard setting, and that's a big portion of what we do. Research is another area where if the industry feels like there's a hole or a weakness that we want to address, we can either pool together funds or find other avenues to try to get research done to, I guess, improve the confidence that everybody has with our products. And then the other area is just expanding the opportunity for the industry as a whole, and whether that's working with specific states on standards and approval or acceptance, or it could be just trying to promote different campaigns. Like today we hear a lot about sustainability and how can we promote that. Resiliency, how do we promote that? How do we just expand kind of the understanding and the acceptance? It kind of moves from just having the engineering details to making people comfortable and interested in the products that are available.
Yeah, and that's something that I want to hit on a little bit is marrying a little bit what you said with the opportunities and specifically with the sustainability effort that PPI is going for, along with that standard setting that you guys have been leading the way and working with a handful of other entities with some of that stuff as well. So I know one of the big things within our industry is use of recycled resin and recycled plastics within pipe manufacturing. So maybe I can let you roll on that a little bit. I know that's been something that you guys do a lot of work with. And
yes, it's been a big portion of what we've been working on, starting with the research, which carried on for several years of working through the research steps, culminating in a federally funded research project that really validated that pipe made with recycled content can achieve the same performance expectations as pipe made with virgin materials. So that was monumental step for the industry of getting to that point so that we had something. But the reality is that as an industry, we've been using recycled plastics for decades, not a couple of years, decades, in the ag industry, in land drainage applications. So our manufacturers and the process used to manufacture pipe with recycling, there's been a lot of lessons learned for decades. So that helps. And then having the additional research that validated its use in public drainage applications was a big step. And so now it's a fixture of what we do. It's kind of mainstream with what we do, whether it's agriculture work or DOT work or things for the cities, counties, what have you. All of it has the opportunity to use recycled resins, which as an industry, I think it makes us very unique. There's not that many industries out there in making a durable good type product that can last 100 years with recycled content. And that's a big step for us. So as an industry, we're using over 600 million pounds of recycled materials a year. Again, there's no one out there who can throw that number up and say that's how much they're consistently using on an annual basis, and getting the performance that we want out of it. So I think it's a great message, and one that unfortunately I don't think the general public has latched onto. I think the general public, I feel this dilemma that the general public, and I've been there, take your recycle bin out and you wonder, is anything going to happen to this, or is it ultimately just going to go to the landfill?
Right.
And I think that we have a message that absolutely we can take a single-use plastic that might have a, I don't know, shelf life measured in months, and turn it into something that has a service life of over 100 years in infrastructure. Mm-hmm. I think that's a great message, and the fact that we're solving infrastructure problems, which we know our country has plenty of those to solve.
Right.
So we're basically hitting two of them. We're solving a recycled plastic issue, and we're solving a need for improved infrastructure.
Mm-hmm. Yeah, and I know you guys did a great job putting together a graphic of showing, the recycling bin of plastic recycling on the sidewalk, and then eventually gets into the storm sewer that's buried beneath it.
Right.
And I think that's a good, a good message, good way of showing that.
Right. We call that our at the curb to under the curb marketing piece.
Yeah.
And we're trying to do more with that. We're actually working on an animated video that kind of carries that same message. Mm-hmm. Again, trying to create content that doesn't just reach engineers or contractors, but reaches the general public to carry that good message. Because unfortunately, there's a lot of negative messages about plastics in general.
Right. It's kind of, if you're plastics, you're all kind of lumped into the same, the same sphere.
Right.
And I really like what you said about, going from that single use to 100-year service life in some infrastructure, durable goods, or however you want to say it. I think that's something that that we're proud of at Prinsco for being able to do that and being able to help out with some of that stuff, and a lot of it that we've done that we've invested in is a lot of the testing and research with that. I know even from some of your background as well, and maybe you can speak to it better than I, because I'm not much of a material scientist. But on some of the testing that goes into either the research that PPI has done, and kind of the research the testing that goes on at the plants to make sure that the recycled resin that we do get, or whether it be chips or whatever else, is something that can be made into that durable good.
Yeah, there's a couple of things that are kind of the go-to indicators for service life testing of plastic materials. In our industry, even with virgin material, whether it's virgin or recycled, there's a test called the Notch Constant Ligament Stress Test, NCLS test, and that test is an indicator. It's basically looking at crack resistance, which in an aged plastic, a plastic years and years down the line, becomes susceptible to cracking. And so that NCLS test is a good barometer to determine, is it crack resistant? And if it is, then can you quantify that and correlate that to 100-year service life? And then, so that's with any of our plastics, again, that are used, do NCLS tests. If it's recycled, there's a oxidation test, and that's can help. That's a quick test. And then, but the one that's probably more commonly looked at for recycled materials for pipe is the UCLS test, unnotched constant ligament stress. So the difference is a notched kind of is a place to begin a crack. Unnotched says that there's nothing, no starter crack. And so the originating crack would most likely occur from a foreign particle that would find its way into the plastic from recycling. And so that unnotched constant ligament stress test is the one that we use to correlate to service life of pipe made with recycled content. And it's all performance-based. We're not just testing the material and throwing it in. It's a performance-based test for post-manufactured materials.
Right. Yeah, and that was something I was going to mention, that, and I talked about it with some of our material specialists at Prinsco, is the testing that we do on a lot of that stuff. Do it on every shipment of resin that we get in, whether it is the recycled stuff or the virgin. Like you said, it's a little bit different test depending on what it is. Right. But that's something that gives us the confidence to know that how can we make a product that meets the standard, is processable, and still, conscious of all the other stuff that we need for that long service life and everything with that too. So, and like I said, that's something that we do day in and day out. We built a facility for that. It's kind of fun going in there and talking to some of those nerds, I guess, that as both of us sitting here as engineers getting to talk about UCLS and SCLS testing.
Right.
So
you don't have to go very far down that road before you're a plastic nerd.
Right. Yeah, exactly. So, and maybe just to hit on, you talked about performance-based test. Talk a little bit about how that relates back to the standards of, performance-based or product performance-based of the ASTM and AASHTO standards that our pipe is held to. Right.
So one of the things that we were very intentional about in developing the standards as we added recycled content to both the ASTM and the AASHTO standards was that we didn't want to be dictated by a specific amount of recycled or a specific quality of recycled. We wanted it to be based on the final performance. And that provides a lot of flexibility then to a manufacturer. Heck, if you come up with a great source of post-industrial resin and it's maybe even better than what would normally go in the pipe, you're just grinding it up and putting it in, then you ought to be able to use that differently than if you're using the post-consumer.
Sorry to interrupt, but talking about post-industrial and post-consumer, you want to just highlight where those recycled resin streams come from? What's the difference between those?
Yeah, so post-industrial would be something that came from another product. Again, I talked about our solid wall pipe brothers. They have pipe that comes out of the ground or that maybe doesn't quite meet their standards. They can't put it back into a solid wall pressure pipe, but it could go into polyethylene drainage pipe. So that's one. Anything that's pressurized, like any plastic that's designed to hold pressure. So even barrels, that type of thing. That's a higher quality plastic, and so that would make great recycled content as a post-industrial. Post-consumer could be any really number 2 or number 5 plastic that we use in our house. So detergent bottles, milk jugs, laundry, dishwashing detergent, even your shampoo bottles and things. There's a lot of number 2 and number 5. They're probably the most commonly used for consumer goods. All those can be used. The unique thing is that, it's great to have post-industrial because it comes at a higher level, but every post-industrial is going to be a different level.
Right.
It's hard to maintain, we're going to have a forever stream up here. You can guarantee you can have a forever stream down here,
right,
and that's post-consumer. So that's one of the drawbacks of post-industrial is the unpredictability of it, whereas post-consumer is very predictable. It's predictably low,
right,
but it is predictable.
And then you just have to be able to combine those together in the right percentages and amounts, and to, like I said, not only meet the standards I need, but the processability requirements that you need on the manufacturing floor as well. And then I guess I did cut you off when we were talking about standards,
that's fine.
But yeah, just getting back to a little bit of, we say that, hey, our pipe meets ASTM 2306 or AASHTO 249 or whatever it is. And you said they both allow recycled resin essentially in about everything now. But maybe want to highlight a little bit on, there always kind of has been that myth of, the AASHTO stuff is the highway grade, is the DOT, is the virgin stuff. As of 2018, 19, I think that's not really the case anymore.
Correct. So in AASHTO, they do require it to be marked as AASHTO M294V or 294R.
Virgin or recycle.
Right, virgin versus recycle. We fought that, but we lost that piece. But we're very happy with a lot of other things. But in the ASTM 2306, it's not required to be marked that way. And so we're still working with DOTs. There are some DOTs that still want virgin. That's just where their comfort level ends. And that's an area we continue to work on. But as an industry, we've been following this roadmap for the last 4+ years, and we're seeing zero difference. And so we're trying to continue to press that. We would love to move to more and more. Go beyond 600 million pounds per year. Get to 1 billion pounds per year. That would be awesome, but the only way we get there is for there to be more demand.
Right.
More demand and more availability of that material, which means more communities recycling, having the MRFs, the processing facilities to get it out and available, because there is, despite what people think, there is a market for recycled, number 2, number 5 plastics.
Right. Shifting gears a little bit to something else that I know PPI is involved with is, on the sustainability front, with the materials and the development in that case, but, also the resiliency is the other buzzword that
Right.
we've been talking about, and that you've been mentioning a little bit about that as well. Want to talk about that?
Yes.
Of what, what is resiliency, your definition, PPI's definition?
Yeah, it's something that we've been struggling with. It's kind of become a buzzword. You hear in a lot of different arenas. You hear it in government talking about resiliency, certainly in the engineering community in general, product resiliency. And so product resiliency is really what we're trying to get to. And most people, the most easy correlation is service life. And so we can talk about 100-year service life, and that's great. But it's really more than that, because some people want to equate resiliency with that it must have to do with disruptive events. Think climate change and that type of thing, of how are we prepared to manage disruptive events. And stressors, things that stress the pipe. Another component of resiliency, if you think of a disruptive event, is recovery. Once you have that event happen, how quick can you get back? And so those are really pieces of it. And another piece of it is sustainability, because it doesn't make sense to create resiliency and destroy the environment. You're kind of defeating the purpose.
Right.
So you want to dovetail in sustainability in there. So service life, being able to maintain through disruptive events, being able to remain in service through different stressful scenarios. And stressors could be anything from just hot cold cycles like you'd see here in Des Moines, or even the hydraulic impact of it. So, or freezing temperatures. So anyway, those are all things that could just be stress, or you could have agriculture runoff that might have a lower pH number. So all those things I would consider as more stressor, as opposed to a disruptive event would be something like you'd see on the evening news, like a hurricane, a massive fire that impacted counties or something like that. So dealing with both disruptive events, stressors, and then one of the things that plastic pipe really excels at is rapid recovery, because A, it's readily available, and B, because of its lighter weight, you can get in and out very quickly with it. And so all those things help in a rapid recovery situation.
Right. And then also, some of the other things I mentioned, the freeze thaw thing. I know there's a lot of pH resistance that HDPE has. I think every company about has their visual of what that means for some of that stuff. So, that's to me, that's always interesting that resiliency component of, I think plastic pipe is very durable in the sense of when you're looking at it from, compared to some other materials. But then also, that's my favorite part about your definition there, is being able to recover from those events too. Yeah, it's not just the durability and the lifespan and whatnot, but you can able to recover back quick when you need to.
Right.
And, like you said, with climate change and whatever else all going on with that, that's going to need to happen.
Yeah.
Might not be at your neck of the woods right now, but eventually going to need to have that mobility in there too.
And different parts of the country face different things. And so I was at the conference I was at last week. There was discussions on resiliency, and they talked about rock slides. Well, I'd never thought rock slides as something I need to prepare for, but that was something that they were talking about, in flooding, ocean levels and things. And I think when it comes to resiliency, everybody has a service life number, but regardless of the product, everybody's got, where's your weakest link? And I think that one of the things that a lot of people don't think about is joint performance. A lot of times the joint is the weak link of a pipe. And of course, in my solid wall brethren, they can weld their systems
There is no
together.
joint.
Basically, there is no joint. But in our systems, even with sticks of pipe, you can have watertight joints. And a watertight joint in a corrugated plastic pipe system is incredibly durable and fit to make it through. Even if you had an earthquake, maybe you don't even live in an earthquake zone, you just have shifting of soil, and having joints that can endure that's got to be a part of your resiliency. And I think plastic pipe does very well in that arena, especially compared to the competing materials where their weak link probably is joints.
Sure. Yeah, and I know another one, and maybe not weak link, and that's not necessarily where I want to go down with this, but is from the plastic pipe industry has installation, recommendations. It's more installation sensitive than maybe a concrete pipe where you can throw down in a hole and backfill, and you might have some different issues later on. But
Right.
With the importance of proper backfill, proper installation on a lot of that stuff, and it was kind of funny. You and me were just talking about recently on some projects that you've seen that maybe got over-installed a little bit too much.
Yeah.
Usually we're dealing with deflection on, pipe is maybe ovaling out a little bit here and there.
Right.
But you've seen it, the other way is, or,
Yeah.
you see it's gets back to, a little bit of that durability aspect of
Right.
it too, where
certainly
it's a strong product.
You're talking about your system. You want your pipe system to last, and part of that is installation. So you have to have proper installation to assure that the system is going to last what you're expecting it to. Poor quality installation is going to decrease that potential service life. So installation is important, and it's a big deal to us. We speak on it at conferences like this. We have content in our handbook. We have, we do webinars. We do have recorded webinars. We have different training modules. Anyway, a lot of different ways you can get installation. And because we want to assure proper installation, I really think that any pipe manufacturer, regardless of material type, should. With plastic pipe, we're confident that you can install plastic pipe correctly faster than you can install a lot of other pipes wrong. And so I'll take that. I would rather be installed correctly. And that's what we're after. And sometimes people feel like it's way too much compaction that they need to put in it. And I guess you're alluding to the situation where I've shared where they had some excessive compaction expectations, and the result was actually a vertically ovaled pipe. And, the bad news was the pipe was deflected.
Right.
Good news is you don't have to spend so much time next time getting that compaction, because we don't normally see positive vertical deflection, but
Right.
It all comes down to picking the right backfill material and the right compaction combination to go with it to get your pipe to last as long as you're trying to get it to.
Right, exactly, and that's another conversation just had with with an installer of, he was kind of hitting home that point of, if these things are designed to, the plastic and the pipe to last 100 years when it's installed properly, it's like, let's make sure, especially on some of these larger projects, I'm thinking mostly on the ag side of things, large county mains and stuff like that. And he's like, we shouldn't be afraid to, spend a little bit extra money for maybe some gravel or some compaction, or,
Absolutely.
take a little time out of that installation to make sure that, these products, this pipe that we're putting in the ground is going to last to that service life that
Right.
that the research supports.
Yeah, I mean, those ag drainage mains, some difficult installations. I mean, depth of cover, the
Conditions that you're
conditions
dealing
that
with.
they're dealing with, groundwater tables. I mean, there's a lot of things in that make it a challenging install. And so, yeah, there ought to be some forethought into how do we get this right. And if that means bringing in some imported material, I would be supportive of that. But, or it could mean going from polyethylene to polypropylene, to get yourself some more stiffness in your plastic. I mean, that's another direction you could go to try to get to that point. I mean, again, what we're after is quality installations.
Right.
And that's going to serve everyone well, and certainly ag drainage mains would be one of them.
Yeah, and now that you just brought it up, it got me to thinking a little bit. We had a previous episode where I spoke a little bit about polypropylene and the use of some of that stuff. Maybe if you could, little bit of time on polypropylene pipe, and you said it's a little stiffer product. What applications would something like that be suited for?
Yeah, there's hardly anywhere you would say that you have to use polypropylene versus polyethylene. I mean, there's not that much different, especially if you install them both correctly. If they're both installed exactly the same, there's very little performance difference. The difference is that if you have challenging installation situation, or if you have a situation where you cannot handle 5% deflection and you want less, or if you have a contractor that you're less confident that they know what they're doing, having some additional pipe stiffness in those situations might not be a bad way to go, because the additional pipe stiffness under the same installation, the additional stiffness will show itself in less deflection. A small amount, but a little bit less. I mean, it could be the difference between, somebody just haphazardly putting in polyethylene pipe and getting 7.5 versus somebody doing the same installation with polypropylene and getting 5.
Right. You get a little added benefit there, a little more peace of mind maybe on some of that stuff.
Right.
But that's kind of one of the messages that I've used talking with customers and whomever else is like, but just because it is a polypropylene stiffer product, it's still a flexible pipe, and a stiffer pipe doesn't negate a poor installation.
Correct.
Like I say, it can help cover up a little bit here and there.
Right.
But,
and the other area that comes not just deflection, but is in joint performance, the consistency of joint performance. That little bit of extra stiffness helps eliminate the variability, and if you eliminate the variability, then that increases the confidence the contractor has if you're doing a post-installation joint test, a hydrostatic test or air test or something.
Right. I appreciate your time here, Dan. And maybe to wrap it up a little bit, you mentioned with PPI, you guys got a website. You got all your webinars on there. It's a fantastic resource for, for the handbook that has pretty much everything, plastic pipe and design and installation and testing and everything with that.
Right.
And like I said, a lot of resources on your website there. And so I encourage everybody to check that out if there's some of those questions. If not, I'm sure we can link your information in the bio, or reach out to myself too. So
yeah, we had never had a plastic pipe industry handbook until 2 years ago. It was about a 6-year period to get us to there. But it was well worth it to now have a industry handbook, and it's available off our website, plasticpipe.org/drainage. You can download individual chapters of it, or you can order a whole book for yourself. And with the individual chapters, that's kind of what we've kind of used to generate some webinars, so to talk through some different ones, whether it's installation, design, hydraulics. We've done all those sessions, and so we're trying to make that as readily available as we can, and having members like Prinsco to share that with your customers, with the engineers that you all come in contact with. We just want to spread that word now that we finally have an industry guidance. So
awesome. Well, that sounds like a great spot to end it.
Yep.
Like I said, I really appreciate your time here today. Appreciate your service to the country and the Navy. Appreciate your service to the industry within plastic pipe, and a lot of the work that you've been doing over the years. So, like I said, thanks for your time. Thanks for coming in, and you can enjoy the rest of the expo, the rest of the conference.
Good deal. Thanks, Trey.
Thanks.
Thanks for joining us today on the Water Table. You can find us at watertable.ag. Find us on Facebook. You can find us on Twitter. And you can also find the podcast on any of your favorite podcast platforms.